Hello dear students. Uh, Today we are going to get see the most important thing, that is EMF equation of alternator. In the last lecture we have seen that EMF is going to get induced. Means we have seen the working principle of alternator, in which we have provided the DC excitation to the rotor field winding. DC excitation is going to get produces the magnetic field which is having constant nature, but as we are going to get drive the rotor by utilizing the prime mover, so it will going to get converted into rotating magnetic field. Now this rotating magnetic field is going to get flow through the air gap between stator and rotor, and it will going to get interlinked with the stator winding, or we can call the armature winding of a alternator. This winding is going to get cut by the armature conductor, and EMF is going to get induced according to Faraday's law of electromagnetic inductions. Now for this there is EMF equation of alternator is there. For designing the EMF equation we will require few parameters. Before proceeding towards the equations, EMF equation question is a very important question and occurs so many times in SPPU university papers of electrical machine 2. So now we are proceeding towards the EMF equation of alternator. For this we are going to get define the terminology. Terminology is, we are taking capital P, which is the number of poles. Then we can take a small f, which is the frequency in hertz. Then we can take phi. Phi is flux per pole in wavers. Then capital N, which is equal to rotor speed in RPM. Then we are taking the next term is Z with the suffix ph. So Z is the number of conductor or coil side covered in series or connected in series per phase. Then we can say turn. For turn, it is a capital T is coming out with again suffix ph, which is equal to number of turns connected in series per phase. Then here we are going to get introduced two more factor. One is called it as Kc, is called it as coil span factor, and another is called it as Kd, it is a distribution factor. Capital K is the capital in coil span factor as well as distribution factor. Basically AC generator and transformer EMF equation is looking like is the same, but the difference which is created is because of these two factors. One is the Kc coil span factor, another is the Kd distribution factor. So remember these two factors. Now let's start the derivations. Already we have seen the working principle of the alternator. So we will start with the working principle. First step is, flux cut by each conductor in one rotation is given by flux produced multiplied by number of poles. So d phi equals to phi multiplied by number of poles. Then step second, time taken to complete one revolutions is given by 60 divided by capital N seconds, because here we have taken capital N in rotor speed in RPM. So dt equals to 60 divided by capital N. Then step 3, average EMF induced in one stator conductor is d phi by dt. So next step is d phi by dt is equal to flux produced multiplied by number of pole divided by the time, 60 divided by the N. This will going to get convert the equation phi multiplied by P multiplied by N divided by 60 volt. This is the average EMF induced in one stator conductor. Now for one phase we are required. So in step number 4 we are going average EMF induced per phase. So whatever the average EMF induced in one stator conductor multiplied by number of conductor, that is a Z phase. So the next step is coming out, average EMF induced per phase is equal to flux multiplied by number of poles multiplied by speed divided by 60 into ZPH. After this step, if you are looking towards the equation, then from this equation you can see there is a speed n is available, and this n is given by 120 f by p. This is the synchronous speed of the alternator. So putting this equation in this equation and just equating the things, so you are going to get finding out a new term, average EMF per phase is equal to twice of frequency multiplied by flux multiplied by Z phase in terms of volts. Now this is average value. Normally we are utilizing RMS value of the EMF. So we are converting this average value into RMS value, and for conversion we are having the standard is called it as form factor, which is equal to 1.11. So we are utilizing the formula form factor is equal to RMS value divided by average value. So we are putting this. So next step is there where we can say RMS value of EMF per phase is equal to average value per phase multiplied by form factor, which is equals to 2f multiplied by flux multiplied by ZPH multiplied by 1.11. So here you are getting RMS value of EMF per phase is equal to 2.22 multiplied by frequency multiplied by flux multiplied by ZPH volts. This is called a EMF equation of alternator. In these equations, up till now we have not considered the Kc and Kd, wide span factor and distribution factor. So if we are going to add these two factors, then we can going to get called as a distribution factor and wide span factor is added. So next equation is going to get coming out EMF or RMS value of EMF per phase is equal to 2.22 multiplied by Kc multiplied by Kd multiplied by frequency multiplied by the flux multiplied by ZPH in volts. But already we know that, because sometimes what is going to happen, the examiner can ask, or the question is coming in terms of ZPH, instead of ZPH it will coming out in TPH. TPH is number of turns is given, which is connected in series per phase. So the formula is T phase equal to Z phase upon 2. That's why the Z phase equal to twice of T phase. So we are going to get introduced in the above equations, that is the RMS value of EMF per phase is equal to 2.22 into Kc into Kd into flux into frequency multiplied by twice of TPH, and hence we are getting the final equation EMF per phase or RMS value of EMF per phase equals to 4.44 Kc multiplied by Kd multiplied by frequency multiplied by flux multiplied by T phase volts, and this is called EMF equation of alternator. This is the full EMF equation of alternator. If you are compare this equation with transformer, then you will finding out there is a basic difference of Kc and Kd. Thank you.